Which one should we start?
Part one, please. So yeah, this one.
Okay. Yeah, this is the one that we did last time.
Is this the same one?
Like, remember I asked, like, there are multiple ways to do it. Okay, let's
Yes.
open
Mm-hmm.
this thing. Here, I said, like there are multiple ways to do it. Like, if I want, like, put both at the same place from other side or whatever.
Exactly. Yeah. So you know,
So
on this
here, hmm,
yeah, on this document on page 3, I think that's a little bit different. If you go a bit low, yeah, this bit here.
okay, one second, I'll open that, like the PDF that we used while creating this. Okay, so I see a difference. Here you
Mm-hmm.
see that the longer part is pointing
Yeah.
towards this.
Mm-hmm.
Here, the longer part is pointing outside.
Mm-hmm.
So that's a difference.
Yeah.
Other than that, nothing else. It's just, yeah, what they are doing is, instead of putting like both of them adding through one opening, they are creating two opening, one on this side, one on other side, and then pressing it inside. So
Right,
should
I
I
got it.
modify
Yeah.
this?
Yes, please. Could you modify it, please?
Mm, something else that needs to be modified. Shadows. Okay, so for consistency, okay, let's change these things. Oh, this was 72. I believe this was 17. 11. Yes, it's 17. It's not this 20. hole, then another of this,
Mm-hmm.
starting from here and again. So now we have like two of these slots
Yeah.
to put the things, like the bearding.
Mm-hmm.
I guess this like covering is also not necessary because they are not doing it.
Mm-hmm. Okay, you can just cut this out.
Yeah.
Mm-hmm.
Now this needs to be different.
Yep, the shaft goes right to the end, doesn't it?
Yeah.
Mm-hmm. Okay.
And I see like a notch kind of thing that's happening there.
Mm-hmm.
I don't know. I'll just create it. Oh, before I do all of it, I just rotate this thing.
Yep.
Although it doesn't really matter. But like, just draw like a rough thing.
Mm-hmm.
Notch. I don't know why this notch is here, but it is what it is. A point 0.5 by point 0.5 notch.
Mhm.
Okay, we need to also redefine the joints because like we changed the body that it was used.
Okay, so you change the joint.
Yeah.
Yeah.
Not change the joint, like just do it again because you see like it's referencing the wrong thing
Hmm.
because it was like reverse previously.
Yeah. So it's a different motion.
No, no, same thing. Just
Motion.
previously I was referencing this other plane because it was like 180 degree rotated.
Yeah.
Now I'm referencing this other plane because it's not rotated.
Hmm.
The motion is same, it's rigid.
Okay. Yeah. Got it.
Same thing with this. Motion is same, that
Hmm.
is revolve, but previously we had a plane over here, small circle, but now we
Yeah.
don't have that. So we use other things
Hmm.
like center of that, then center of that. Now it rotates. Okay. Okay, that fixes the issue. Well, there was no issue. It's just two ways of doing it.
Hmm.
Oh, there's more.
And
Okay,
this one's
currently
done.
there is nothing stopping. There's more. Like it says why there's a notch here. The reason behind the
Hmm.
notch.
And then it says that to put to do engineering drawing, but we don't need to because I already know how to do them now.
Mhm. Oh, it's you have to
It's a bit threaded.
so that you can put a bolt in here. Okay, that makes sense. So I extend this thing by let's say 10 millimeter, and then is the whole thing threaded? I don't think so.
No, it looks like it's just a ball.
Okay.
Let me check. Yeah, it's just the end.
Mhm. Okay, so you need to create a thread, you come here and click on thread, and then you
Mhm.
need to untick full length and then define a length 10 millimeter in our case. And it will only be for 10 millimeter. Let's make it modeled and everything else can stay. So if I hide this, it's still here.
Mhm. Perfect.
Okay, so next let's create this click. Do I create this clip or download it from somewhere?
Sorry,
Um,
exactly.
do you have this like model or do I need to create it or
I'll check now. We have the disc and the caliper,
No, that's a
which
completely different thing.
yeah,
Disc and
that's the
caliper is a different. Oh no, it's part of the same thing. No, it's braking system. It's different.
it's different. No, I think we're gonna have to create it.
Okay, no, no. It says that find it from. Let's see if there's something like that.
No, you don't need to create the circlet.
Oh, no, I'm not creating it. I'm just finding it from somewhere
Yeah.
because yeah, it gave all the details and just.
Yeah.
Dun, 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 dun. I need 34 in. Yeah, this is not right.
So what are you trying to do?
I'm trying to find the correct clip size. Like I downloaded a 35 one, but it says that it is almost 32, not 35. So it's mislabeled. So I'll download a 32, 35. This one. Is that correct?
Me, if it's
Are
not
you
correct,
sending me something?
yeah, I sent you something, but it's not for this task. It's for the other one. But this one I can try find it myself. If not,
Yeah, it's just the. It's okay. Like one was too big, one was too small, so the middle one works. Hopefully. So I did 35 and 38. I'll do 36 and I want the standard one.
Mhm.
The smaller thickness. And let's do that. If this does not fit, I'll just change the groove height.
Okay.
Yeah, this fits. So yeah. So this will match with this. Okay. let's move on.
Awesome.
Because this fits well almost it's whatever. And this it will it will fit after you tighten it.
Hmm.
What matters is this. Okay, what's next?
The next one is
No, no,
I've
let's
sent
see
it.
if there's something else in this.
Yeah, it's just the engineering drawing, I think.
Yeah, do you know how to create this?
Yeah, I can create that. Thank you.
Like changing material and stuff.
Can you just show me that quickly, please?
Okay.
Thank you.
So,
We don't
so
have to
this,
actually make it.
okay. So this is not appearance. Appearance and material is different.
Mhm.
So if you go to if you go to appearance, this is where you give it like different colors.
Mhm.
Sure. Mm, This is where you give it different color. But
Yeah.
there's also this thing called physical material.
Mhm.
Here you can change it to, let's say by default it's all steel.
Yeah.
But if you want it to change to, let's say, aluminum, you can change, let's say this thing only, because the other things are like referenced from other file. So I have to open that file and change it from there. Okay.
Oh, okay. Yes.
But I have changed this thing, the shaft, to aluminum. So this is aluminum and everything else is steel. So I
Hmm.
already have that one here. So let's just open it. Let's also save this thing. So I save this and it should tell me to update reference.
Yeah.
Whatever, don't worry about this because there's nothing to different, like there's nothing to measure it over here. So that's why it's failed. But yeah, let's create a table, put it over here. You
Hmm.
see that the shaft is aluminum and everything else is steel. And it
Yeah.
also creates this thing. If you want to create more, there's this balloon option that you can use like so here, and 4 is shaft. And I can select here 2 is whatever pulley. Okay. And you can double click here and let's say you want to show description. Now there's nothing shown in description here. How do you add it? You
Hmm.
need to come in here, and if you right click on any of them and there's properties,
Yeah.
in properties you'll see that the name, part number, that is referenced over here, and there's also description. So you can write something here, and let's say I want shaft, part number can be shaft 1, something now.
Mhm.
And let's save this. You'll see the description and everything pop up here.
Yeah.
But there's some problem with reference, but it will pop up here.
Hmm.
Okay. That's why you change the description and stuff.
Got it. Yeah. Easy. Thank you.
Alright. Let's then next one.
Yeah, I think I can do this one myself, but the one I just sent now on Fiverr, that's the one I need help on. Yeah, just this one, please.
Mini mock exam. Company shows your time belt pulley. Yeah, it's the. Yeah, can you send me all this?
Yeah, I've sent it. I've sent it already. It's at the top.
Oh,
Yeah.
like it's the same thing as before. It's like you don't have to design anything. You just place it in the correct orientation. That's all.
I practiced yesterday's one, so I've kind of got like a more understanding of how to do it now.
Mhm. Okay, so can you tell me what to do?
Yeah. So first you'd put all the models into Fusion.
Mhm. What should I name this file?
You can name it just mock exam for now.
So first of all, I which one is the first one? Let's say the pulley. So
Yeah.
I pull in the pulley thing
Hmm.
and make sure that the first one is locked or like anchored so that like you can reference everything else from this first one
Hmm.
and then like orient it properly.
Yeah.
And it's a good idea to keep this on so that you can see that it's like at the middle of everything, which is good.
Yeah.
90-degree, and is it in the correct orientation? Yep, correct.
Then you put the coupling, no, the bearing. Yeah.
Bearing. All right, and like correct the
Orientation.
orientation, and it says almost 100. And you see that it is not aligned properly.
Hmm.
So what we will do, we will use point to point to align them properly.
Yeah.
And we'll say that the center of this circle will connect to center of that circle.
Hmm.
And then we will use freedom to give like distance.
Yeah. And the distance is 50 mm.
Oh, 50. Okay.
Hmm.
And is there another one of these?
Yeah, the same thing, another bearing.
Okay, you can copy this thing, but a better idea is to uh, like
Drag it
just
in again.
drag in again, because then what will happen is if you want to change anything later on, you can just change in the original file and all of it will get updated.
Hmm.
So it's like a better practice. Just move it in a different, and then point to point, that do
This is
that.
also 50 mm as well.
Okay. And then the coupling.
Yeah. The coupling is 40 mm away.
That's it.
Mhm. And then you have to make a shaft, and the shaft should be with an output 12.7 mm.
Other end of the coupler is connected to. Let's understand what the coupler is doing. Okay, okay. So this is like a vibration isolation thing, isolating thing,
Mhm.
using the spring kind of structures. Okay, that makes sense.
Yeah.
Okay, that is later on. 12.7 is the inside thing. 12.7.
Says 12.7. Yeah, I think it would be
Yeah,
the
it's
inside.
12.7. Yes,
Yeah.
yes, it's 12.7. Okay, then let's create a shaft. Okay, there's something we need to consider, that in this
Mhm.
case, like this will not be a concern now, but it will be a concern when you create the simulation.
Mhm.
Like these things are fixed. This moves and this moves. But while creating this, we placed this first. So we have what the way we have done. This is fixed, but everything else moves, which is not correct, right?
Right.
Yeah, so we'll need to change that. And we will need to unground this and we need to ground these two.
And you're gonna
Ground.
ground the both bearings.
Yeah, I'll ground these two because these are the fixed points and everything
Yeah,
else
and you
rotates.
should move.
All right, let's create the shaft. Uh, let's create a section. Oh, no, let's do that. And you can click on this slice to like create a section in that.
Mhm. And that's just section analysis, isn't it?
Section analysis, but you don't have to do the whole thing about like there. You see, there's no analysis over here. You can
Mhm.
just click on slice, and it will slice till the plane on which you are working on.
Okay.
And let's create a. Is this straight? That looks good. Easy. Yeah, it is. Oh. Mm, yeah, so let's create that and place it. I think let's go steel something here like that.
Mhm.
Right now about giving constraints. So that touches that. There is a line between here and here.
Use a
That
vertical
line
constraint.
is vertical, yes. And we need to get some points. So intersect. It's at this point. I want that point. this point, that point, also this and that,
Mm-hmm.
and maybe this one also. What happened to this mouse? What? Oh, these are, never mind. Right, constraint here, wrong constraint that, that. These are all just like coincident constraints.
Mm-hmm.
All right, here's the shaft, and let's give it. Actually, okay, are you here?
Mm-hmm.
So when multiple groups are like rigid or they like move together, you instead of giving like joints normally, you can also create a rigid group. And like let's say right now these three can move separately, right?
Yeah.
Oh, okay, my bad. This one.
And you can ground them as well.
No, I will 1 second. Let's create a shaft component. This sketch goes in this component, and then we do this. Then we do that full body. Okay. Yeah. So right now, what's happening is this can move freely, this can move freely, this can move freely. What I
Yeah.
want is not to ground them, but make sure that they three move with each other.
Mm-hmm.
So I can define a rigid group and say that these three components are part of a rigid group,
Yeah.
and now they move together,
Mm-hmm.
which is what we want. We also, so is it, let's see. We can also give it like a joint to make sure that they rotate instead of just moving around, but it's not
Yeah.
mentioned here, so no need.
Awesome. And you know when it says to create the drawing of a mechanism, is that just a normal engineering drawing or is it
Yeah, yeah.
different?
Engineering GA drawing. What is GA drawing? Of the mechanism means just the thing. That's nothing. Oops.
It's nothing special. It's just the same thing.
Yeah,
Hmm.
GA drawing, general arrangement. So like the just the assembly drawing, nothing special.
Oh, okay. And
We also
I
need
just
to show like the cross section to make sure that the
the
sizes are
cross
correct.
section.
Mm.
I got it. Yeah, I can attempt that myself. Thank you. And it says the third thing is the stress of
Analysis.
the, yeah, the stress in the shaft given. So the pulley has a load of 2,500. Could we just go over that again quickly, please?
Mhm. That the pulley sustains a vertical load. Okay,
Yeah,
so a
and then
load
the
is applied from here down by 2500 Newton. The coupling will exert small vertical load,
oh, 50.
mhm, like vertically up or vertically down.
Mm-hmm.
It was a question.
Oh, I think it'd be vertically. I don't know. I think probably vertically down, but it's okay. I can ask my teacher
No,
and
no, no,
then.
no, 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 no. I think it will be vertically up because
Oh, right.
the pulleys are the thing that's holding it, right? Like if you have a stick and the stick is you are holding that stick, then you are putting a pressure vertically up. That's what my logic is. You can ask and verify it.
Okay. Yeah.
Do you understand what
I'll,
the logic that I'm giving?
a little bit. Could
Yeah,
you
like
clarify?
yeah. So if you have so these are rigid. If
Mm-hmm.
you have a force downward acting in this point,
Mm-hmm.
then to balance it out, like how do I show? Like these are rigid, so like you have a pencil, you have a pen.
Yeah.
A pen is sticking out of your hand a little bit.
Mm-hmm.
Now you add a force downward to the end of the pen,
Yeah.
the hand on which you are holding the pen. That hand
Mm-hmm.
is acting a force upward, right?
Yes. Yeah.
Doesn't matter. Let's just do this simulation. Stress analysis. So at first, we have a new study. We might want to simplify something, but no need.
Mm-hmm.
The material, nothing mentioned, so I'll just leave it as steel, which is by default.
Yeah.
Constraints. So constraints are this is fixed, that is fixed.
Mm-hmm.
Okay. Now what else? Load.
Yeah.
Load. Uh, where is the load? On the pulley or on the shaft of the pulley?
I saw the shaft. Um. Oh no, the pulley. Yeah. The pulley.
Okay. So I'll just select like the outer edge. This is the of the pulley
Mm-hmm.
and at an angle of like 90 degree because it's acting down. Okay.
Yeah.
Magnitude 2500.
Mm-hmm.
Mm, As you can see, there are like different kinds of load.
Yeah.
Force. Yeah. And there are two mm, other loads applying upward. How do I show it here? Mm, That's over here. Upward by 50. Correct?
Yeah. Yeah. Correct. But it says the pulley is 2,500 and the coupling is 50.
That's what I did. So we have
Mm-hmm.
two loads, 50-50 over here and one to 2,500 down.
Mm-hmm. Perfect.
Okay. 50-50 is not shown. Yeah, it's shown. And then these are different bodies, right? We need to like create a contact set, like so that it does not just clip inside. If that makes sense. So I'll
Yeah.
say everything inside, like everything that is within 1 millimeter should like act it as if they are like on top of each other.
Mhm.
Okay, and what else? Yeah, then we also need to create a mesh because the mesh is what how it measures stuff. So you
Yeah.
can see that there is like the more finer the mesh, the better the
So
result. Yes, but let's just leave it as default. Right. Is there anything else that needs to be shown? Like you can do while this thing takes its time.
no, that's the only thing left.
Yeah. Like the rest is like same as it was. Like there's nothing else to it.
Mhm.
Okay.
It's pretty much easy when you get your
Yeah,
head
it's done.
around
It's
it.
done.
It's really easy.
It's done. It's done. Okay, so you just like go in the order of whatever it's showing over here, right? You first
Yeah.
create the study, you simplify things like if there was a multiple other things that was not needed for this simulation, you can click on simplify and get rid of them
Mhm.
so that like you are not unnecessarily processing a bunch of things.
Mhm.
Change material if you want to, constraints and load, we did all of that. DOF displays, DOF view is if there was something that was loose. Like
Mhm.
imagine there was another uh, cylinder over here that was not connected to anything. If I apply
Yeah.
force to it, then obviously it will just fall.
Mhm.
So DOF view just if you can see here, if it's free, it will be red and like that. So it just
Yeah.
makes sure that like you need to make sure that all of it is green. Otherwise,
Mhm.
it will create some issue depending
Yeah.
on the use case.
Mhm.
If you want it to free fall, then yeah, whatever. And then yes, solve.
And when it solves it, does it show like with the colors, like when the where the breakage is and with all of those?
Yes, it will. Like it shows where the like that's the main task, right?
Yeah.
Uh, Showing where the maximum amount of stress is
Hmm.
and where it might break.
Yeah, exactly.
So, so yeah, most probably for this use case, it will all be green. So like you can try like putting extremely thin shaft and doing it, or putting like extremely high load. It will show like where it
Mhm.
will fail.
Yeah, very slow.
Yeah, 2500. So it's 250 kgs,
Hmm.
and it's a fairly
Heavy
yeah, it's
piece.
almost a 4 centimeter radius, like 4 centimeter dia thing. So it will probably be fine.
Mhm. So I have a question.
Mm.
So you know when you're because this is for my exam, how do you think I should present the findings? Like just screenshot it and put it into a Word document.
Yes. So if I have any other thing, like it actually creates a report, but
Mhm.
the report is most likely not needed.
Yeah, I remember you showed me the report last time of all the stress that it generated.
But it's if they ask for one thing only, then yes, you can just take a screenshot and present it in that way.
Mm-hmm. Got it. Thank you.
Why is it taking so much time? Let's just wait. Yeah, it's done.
Cool. Let's see.
And it's all in blue.
Mhm.
And like while showing, like if you show it in the, like while taking the screenshot, if you show it in that exaggerated form, then I think
Mhm.
it's
And what does the blue mean?
blue means that, okay, so this is displacement, right? So it says that there is almost no displacement over here. There is
Mhm.
only, like there is more displacement. Like you can see the scale over here,
Yeah.
0 to zero point 0.8 or something. And the more towards zero point 0.8 it goes, the more redshift.
Mhm.
Okay.
And does the
And
blue mean like it's very strong as well?
uh, yes, but this is not the, this is where it shows displacement. If I
Mhm.
show stress, then yes, well, it's blue, it means it's strong. And also everything is blue, so everything is fine.
Yeah.
But, yeah. So yes, blue means that there is less deformation, less strain, less stress, everything. The less it is, the bluer it is. Like that.
Mhm. And if you put it on stress, it'll be all blue.
Yeah, it is all blue. You can
Yeah.
like try to do like make it like 1/4 the diameter, and then it will show red or yellow over here.
Mhm. Got it. Yeah. Thank you.
All right. What files do I send you?
Could you send me this one? This one as well. And yeah, you don't need to send the stress one. That's okay.
Mm, this one. I don't send this.
Mm, yeah, can you send this one?
Yeah, this is the stress one.
Okay, yeah, this one, please, and also the first one.
Yeah, this and that, right? What else?
Yes, please.
What first one? Like
Um,
two, right?
yes, two.
This, there are issues
And
with this thing, right? So do I just leave that or get rid of these issues?
you can just leave that. I don't need that.
Whatever, that's fine. Well, not fine, but yeah, whatever.
Mhm. Yeah,
There's
just
overlap, whatever.
and could you send the recording as well, please?
Yes, I will.